Welcome back to Hypnosphere. This is a quiet corner of the internet where science is allowed to breathe, where curiosity stretches out and takes its time, and where the night sky becomes a soft invitation rather than a puzzle to solve. If you are settling in for rest, or easing into a long drive, or maybe just letting your eyes wander while your thoughts go calm and slow, you are in the right place. Tonight we will wander into a question that feels so simple that it almost disappears when you stare at it, and yet it reshapes how we think of everything. Why does the universe have no center, and what does that really mean for us? If it feels natural, you are welcome to share where you are listening from and what time it is for you. I like imagining the quiet dots of people scattered across the globe. City lights reflecting on windows, porches with crickets, the soft hum of a radiator in a winter room, or the low open stillness of a night drive. There is something beautiful about learning together in that gentle way, across time zones, across seasons, across the rhythms of our separate evenings. The idea that the universe has no center can feel like a riddle. In our ordinary lives, almost everything has a middle. A table does. A football field does. A town has a main square. A park has a fountain. A house has a living room. Even the word middle is comforting. It suggests a place where things begin to fall into place, where you could put a map pin and say here. So when astronomy tells us that the universe has no center, it can sound like a trick, as if the science had slipped into something too abstract to be real. But it is not a trick. It is an invitation to understand how space itself behaves. It is about how distances change with time, about how light carries memories outward, and about what we mean when we say the word universe. It is not that there is no center, because everything is chaos. It is that the geometry of space is stranger and more generous than we first imagined. The lack of a center is a sign of a deep and quiet symmetry, a kind of evenness that repeats in every direction when you look far enough. If you have ever heard the phrase the Big Bang, you might have imagined a firework, white hot and bright, exploding in an empty black field. That picture naturally suggests a center, the place where the firework launched from, the spot where the light began. But the true story is calmer and more subtle. The Big Bang is not an explosion within space. It is an expansion of space. That distinction seems slender at first, barely more than a change of wording, but let it sit for a moment. An explosion in space happens at a point in a larger pre-existing arena. An expansion of space happens everywhere within the arena at once. If you are inside the arena, you do not find a privileged middle. Everything recedes from everything else as the arena itself stretches. Tonight, we will take our time with this idea. We will watch how people first tried to place the cosmos around them, all the older ways of drawing a center, and then how those drawings had to be gently redrawn. We will follow the light, the way it reddens as it travels, and the way it tells us about the growth of distance. We will look at simple images that are not perfect but are helpful, like paint on a rubber sheet that is being stretched, or raisins rising in a loaf of bread, or points on the surface of a balloon. We will tread carefully where those pictures fail, and then we will return to real measurements, to telescopes, and to the quiet uniform glow of the microwave background that fills the sky. The meaning will unfold slowly. A universe with no center is not a universe without meaning. It is a universe where each observer has a horizon that is centered on them, not because they are special, but because that is how light works and how distance grows. There is a kind of kindness in that. Everyone, everywhere, would see a similar view. The patterns are larger than any one vantage point. As we begin, imagine the night sky above you, or if it is daytime where you are, imagine it layered behind the blue. Imagine that the map you carry in your mind, the one with north and south, and the routes you know so well, can be rotated and zoomed in until it becomes the great map with galaxies for cities and clusters for coastlines. Then consider how you would place a pin that says center in a map like that. Would it still mean what it means on a road map, or would the concept have to stretch? We will walk into that question with patience, step by step, and see where it leads. In a moment, we will move softly into the older stories of where the center was thought to be, and how human beings have slowly let go of the urge to put themselves in the middle. That process, like the expansion of space, happens everywhere at once when you look with enough care. Before we talk about what the universe is, it helps to remember what people once thought it was. The desire to place a center is human. It is a way to find calm, to anchor meaning. In ancient Greece, Aristotle imagined a cosmos of nested spheres, with Earth at the center. The celestial lights were thought to glide in perfect circles around us, carried by crystalline spheres so smooth and balanced that they became metaphors for harmony. The center was below our feet, and above us everything wheeled in order. If the star circled, then we must be in the middle. The idea was not foolish. It matched the view from the ground, which is where all of us live. Centuries later, Ptolemy refined this picture with epicycles, those small circles riding on larger circles, creating the intricate loops of retrograde motion that planets trace against the backdrop of stars. Still Earth-centered, still circle upon circle. Astronomers could compute the positions of planets with surprising precision this way. The scheme was complicated, but it worked well enough to guide navigation. And beneath the math, there was a comfort. We sat at the heart of a celestial clock. Then, slowly, the clock was turned inside out. Copernicus proposed that the sun, not Earth, was near the center. He did not have all the data, but the idea was elegant. It made retrograde motion an effect of perspective, the natural result of Earth and Mars lapping one another around the sun. Kepler softened the circles into ellipses, and Galileo turned a small telescope toward the night and found moons circling Jupiter, a miniature solar system that did not care where Earth was. The center was relocating. Then Newton joined it all with a law that said objects do not need crystal spheres to guide them. Gravity is enough. Space could be open, not layered with glass. The center, in Newton's language, was replaced by a stage, a vast three-dimensional arena where every mass attracts every other mass. Even this was a kind of center, though. Absolute space became the background you could lean against. It was an invisible fixed grid on which everything happened. Think of ship bearings etched on a calm sea. That grid suggests a natural place to hang a label that says the middle of everything. While Newton did not set a universal center, the way we draw the Newtonian world can make one feel implied, as if the origin of the grid were somehow special. You can choose a coordinate origin anywhere you like, but the background itself is always there, silent and unmoving. When people began to measure the nebulae, the hazy smudges in the sky, the question changed again. Were those smudges clouds within our galaxy, or galaxies of their own, island universes far beyond? By the early 20th century, it became clear that the Andromeda Nebula was not a cloud in our Milky Way. It was another galaxy, as large as ours and far away. The scale of the universe swelled. The idea of a center slipped further out of reach. How would you choose a middle in a space filled with millions of galaxies, then billions, then hundreds of billions? Then came a discovery that altered understanding in a way that forces even very patient metaphors to shift. Astronomers began to measure the light from galaxies and found that most of it was stretched, shifted toward the red part of the spectrum. This redshift could be read like a speedometer. It said that those galaxies were receding, their light elongated by their motion away from us. Sorrows are sometimes said to stretch time. In a literal way, stretches in space lengthen light. The recession was not uniform. The farther a galaxy was, the greater its redshift. That suggested something astonishing. It was not just that objects were moving through space. It was that space itself was expanding. If you picture a field where every stalk of grass grows longer night after night, then the distance from stalk to stalk increases even if the stalks themselves never take a step. If the stalks all grow at the same rate, any creature in that field, crouched beside any stalk, would see the same view. Close neighbors drift a little, distant ones drift a lot. More distant ones slide away faster, because more space lies between. There is no privileged stalk. The growth is happening everywhere evenly. New words began to take on weight. Homogeneous means the same everywhere when you look on large scales. Isotropic means the same in all directions. At first glance, these are abstract terms, but stand under a low, unbroken fog. There is no direction more foggy than another. That is isotropy. Reach out your hand in any direction. The mist feels the same on your skin. Walk a block. The fog does not thicken or thin. That begins to feel like homogeneity. The universe appears to be like that fog, at least when you average over vast enough distances. There are clusters of galaxies and filaments and voids, certainly, but smear your view over hundreds of millions of light years, and the patterns lose their local peaks and depressions. The soup becomes smooth. A universe that is homogeneous and isotropic has no special place for a center to latch onto. In this gentle fog of sameness, the concept of a center undergoes a quiet, almost imperceptible change. The center is no longer a location. It is a kind of symmetry. You can choose any point, and the large-scale universe looks the same. The legal phrase equal protection under the law feels like a distant cousin to this. Equal appearance under translation. Shift your viewpoint, and the laws do not change, the patterns do not break. If that is true, then any talk of a center becomes a choice of coordinates rather than a physical truth. To get a feel for it, Imagine you are floating in a dark ocean with no waves, only a slow swelling that lifts all buoys apart equally. You look around and mark the positions of distant lamps. After a while, you mark them again. Everything has receded. It would be tempting to mark the water under you as the center of expansion, as if you were somehow anchored. But if a friend who began 100 miles away repeats the same observation, the pattern repeats for them. We are not at the center. They are not at the center. The expansion has no middle. It is an action of the whole. In the next part, we will bring this from metaphor into the patient language of modern physics. We will look at how general relativity, the theory that replaced Newton's quiet grid with a dynamic mesh that bends and stretches, leads naturally to an expanding universe without a center. We will listen to the light itself, the soft ancient hiss of the cosmic microwave background, to see what it says about homogeneity and the lack of a privileged middle. And we will return to that lingering image of a firework in the dark and watch it dissolve into something calmer, like a cloud that seems to be everywhere and nowhere at once. The framework that anchors modern cosmology is general relativity. In that theory, space and time form a single fabric that responds to matter and energy. Mass tells space how to bend, and space tells mass how to move. It is a sentence that has been repeated often for a reason. It is simple enough to remember and deep enough to change the way you picture reality. When you assume the large-scale universe is homogeneous and isotropic, general relativity narrows the possibilities for the overall shape of spacetime to a family described by a single scale factor. This factor, usually written as a letter A that depends on time, says how big the universe is today compared to some earlier time. When it grows, distances between far apart points grow in proportion. The fact that only this expanding or contracting factor changes, while the rest of space remains statistically the same, is a kind of mathematical way of saying there is no center. There is nothing in these solutions that picks out a preferred location. Slide your coordinate system anywhere, rotate it by any angle, and the equations describe the same type of world. It helps to return to a gentle picture. Imagine a grid drawn on a very stretchy sheet of rubber. If the sheet doubles in size, every square in the grid doubles. The amount of sheet between any two dots doubles as well. If you had tiny ants standing on the sheet, and if they believe the sheet is all that exists, there is no doubt in their world they can claim to be the source of the stretching. The stretching is a property of the sheet itself. You can choose one dot as the origin of your map. That is your coordinate choice. But a different ant could choose a different dot and still describe the same physics. The phenomenon has no anchor point. Now turn from pure thought to light. Astronomers use light for almost every measurement they make. Light carries memory. It leaves a galaxy and travels across growing space. As the space grows, the wavelength of the light is stretched too, and that is what we observe as a cosmological redshift. There are two ways to tell this story that are both correct and complementary. One is to think of the redshift as the Doppler effect that happens because the galaxy was moving away when it emitted the light. The other, more typical in cosmology, is to think of the redshift as the result of the expansion of space while the light was in flight. Which version you prefer is like choosing whether to think of a current carrying your boat or to think of the shore moving relative to you. Both are useful. Both describe the same relationship between cause and effect. Edwin Hubble and others measured this relationship in the early 20th century. The law that came out of those measurements is simple to say. The recession speed of a galaxy is proportional to its distance from us. Double the distance, and the speed is doubled. Triple the distance, and it is tripled. The constant of proportionality is called the Hubble constant, though astronomers now often call it the Hubble parameter because it changes slowly with time. It is not a fixed law of nature like the charge of the electron. It is a measure of how quickly the scale factor is growing at a given moment. The beautiful twist in this story is that Hubble's law, a simple linear relationship between distance and recession speed, is what you would see from any location in a homogeneous expanding universe. There is nothing special about our vantage point. Place an observer anywhere, and they will measure neighboring galaxies moving away, with recession speeds that increase with distance in the same smooth way. This is one of the clearest ways to sense the lack of a center. If there were a true center, faraway observers would measure something different. They would see a skew, a lopsidedness, but they do not. The pattern is even. If you ask how we know that space looks the same in every direction on the largest scales, the cosmic microwave background offers a quiet, steady answer. This is light released when the universe was young and hot, when the first atoms were forming, and the fog of free electrons was clearing. For the first few 100,000 years after the Big Bang, the universe was a glowing plasma, a little like the surface of the sun, but much more uniform. Light could not travel far without scattering. Then, as the universe expanded and cooled, electrons bonded with protons to form neutral hydrogen. The fog lifted. Light began to stream freely. Some of that light has been traveling ever since, stretched by expansion, until it is now in the microwave region of the spectrum. It fills the sky as a nearly uniform background glow. Measure this glow with good instruments, and you find it has a temperature the same to better than 1 part in 100,000 in different directions once you correct for our local motion. The small variations that do exist are precious. They are the seeds of the galaxies and clusters that would later form. But the striking thing is the sameness. The sky is bathed in a calm, uniform light that was emitted when the cosmos was very young, everywhere at once. There is no bright spot that says here was the center. There is no stripe that says the edge. There is a subtle fingerprint of sound waves frozen into that pattern, and those waves help anchor our distance scale. But the important point for this question is that the microwave sky supports the idea of homogeneity and isotropy on the largest scales. If you have heard that the universe has a rest frame defined by the microwave background, you might wonder whether that frame acts like a center. It does not. The frame is like a calm in a gentle current. We are moving relative to that calm, and that motion produces a small difference in the microwave temperature. Between the direction we are heading and the direction we are leaving, a dipole pattern that instruments can see. If you could bring your motion into balance with that calm, the microwave sky would look maximally uniform. But this does not pick out a location. It picks out a state of motion. Any galaxy anywhere can adjust its motion to remove that dipole locally. A rest frame is not a middle. It is a way to say you are drifting or not a place you can point to in space. It is also fair to ask about the part of the universe we can actually see. Our observable universe is the sphere of space from which light has had time to reach us since the first atoms formed, and, more generally, since the early moments of expansion. That sphere is centered on us by definition. That often confuses the question. We are at the center of our observable universe, not because we are cosmically important, but because that is how observation works. If you stand under a street lamp, the circle of light on the ground is centered on you if you define its edge by how far your eyes can see clearly. Walk across the street, and a different circle follows you. Every observer is at the center of their own observable universe. That is a local, practical center, not a global one. It does not contradict the lack of a center in the whole. What about the beginning? Does not every beginning have a point? Here again, the language matters. In the models that match our data, the early universe can be described by a scale factor that shrinks toward zero as you wind time backward. If you imagine that all distances go to zero at once, then the Big Bang is a time, not a place. It is a moment when the density of the universe was very high everywhere, not a point in space from which everything flew outward. In the technical language of the equations, the singularity is in the past of every observer. It is not a spot that you could travel toward now, like a mountain at a distance. It is a boundary in time when the description you are using stops working. You cannot fly to the Big Bang. It sits behind you as a universal before. This story also naturally makes space for the observation that the expansion is accelerating. Distant supernovae serve as standard candles, and when their light is compared to their redshift, the pattern implies that some form of energy with negative pressure is driving a gentle acceleration. We call it dark energy, a placeholder for something about the vacuum that pushes rather than pulls. Its presence does not create a center. It modifies how the scale factor grows. The lack of a center is a feature of the overall symmetry. It persists through faster and slower phases of growth. In the quiet that follows these pieces, notice how the questions soften. If every point can serve as an origin equally well, then being at the center is not a privilege, but an artifact of the way we draw our maps. And if the beginning is a time shared by every location, then the word big in Big Bang starts to mean large in scope rather than spatially concentrated. In the next part, we will slow down with gentle analogies that many people find helpful, then explore their limits, and finally let those images teach us something clear. There is no center, not because we are losing something, but because the universe holds a larger symmetry that our first pictures had room for. Analogies are like handrails in a darkened hallway. They are not the room itself, but they help you move with confidence until your eyes adjust. The most famous analogy for cosmic expansion is the surface of a balloon with dots on it. Imagine painting small circles evenly across the balloon. As you inflate it, each circle moves away from every other circle. The farther apart two circles are, the faster their separation grows. There is no preferred dot on the surface. Pick anyone, and you will see the same pattern. Neighbors that drift slowly and distant dots that slide away faster. That is the same structure as Hubble's law. This picture is useful because it captures homogeneity and isotropy in a simple visual. It captures the clue about no center too. The center of the balloon is not on the surface. The surface is a two-dimensional world. The center exists only in the three-dimensional space in which the balloon floats. If you were a creature confined to the balloon's surface, living only in those two dimensions, there would be no center within your world. This is a good handrail, but it has limits. Our universe is the three-dimensional space itself, not the surface of a higher dimensional balloon. We do not need to imagine a literal outside. The balloon picture is a way to show how a space can be finite without edges, and how expansion can occur everywhere at once without a special point. If the balloon analogy makes you wonder where the center is in real life, the simple answer is that the real center is not anywhere in space at all. The expansion happens in the distances within space. The balloon's embedded center helps you see a property, but it is not something we are trying to find in our cosmos. Another useful picture is a raisin loaf rising in the oven. Scatter raisins evenly through the dough. As it warms and expands, every raisin sees its neighbors recede. A raisin 1 centimeter away moves away slowly. A raisin 10 centimeters away moves away 10 times faster. The speed is proportional to distance because there is more dough in between to stretch. Here again, there is no privileged raisin. This picture makes clear that expansion does not mean the raisins themselves swell. Galaxies are held together by their own gravity. They do not expand with the universe. The spaces between clusters do. The loaf keeps its inner cohesion at small scales, while the large scale stretches. There are nearby exceptions, like the Andromeda Galaxy, that will eventually merge with our Milky Way, because local gravity wins the tug of war. But over hundreds of millions of light years, the evenness takes over. A third friendly image is a rubber sheet with a pattern printed on it. As the sheet is stretched, the pattern keeps its shape locally, but grows apart from other patterns. This helps track the idea of comoving coordinates. In cosmology, we keep track of positions in a coordinate system that expands with the universe. A galaxy that is at rest with respect to this flow keeps the same coordinates, while the scale factor multiplies the distances between coordinates. If that sounds abstract, imagine that cities on a map keep their addresses the same, while you change the scale of the map from 1 centimeter equals 1 kilometer to 1 centimeter equals 2 kilometers. The numbers did not change. The meanings did. These handrails guide us to a deeper pair of questions. Does a universe with no center have an edge? And is it finite or infinite? The answer, in general, is that it could be either finite without an edge or infinite, and the lack of a center remains in both cases. The simplest models that match our observations describe a spatial geometry that is very nearly flat, meaning straight lines behave as they do in Euclidean geometry over long distances. A flat, three-dimensional space can be infinite. It can also be finite if it has a wrapped topology, like a three-dimensional analog of the surface of a torus, where going far enough in one direction brings you back around. In that case, there is still no edge and no center. The place you stand is not privileged. The three-dimensional sphere, which is the set of points at a fixed distance from a center in a higher dimensional space, is another finite, centerless example internally. You can live entirely on the three-sphere and never encounter its embedding center. All points can play the same role. Observationally, we look for signatures of these shapes. Light traveling around a finite universe could connect the sky to itself in repeating patterns. So far, the data suggests that if such a wrapping exists, it is too large for us to see within our horizon. The microwave background looks very nearly flat and uniform, with only tiny ripples. That supports a picture where the universe is at least much larger than what we can observe, and perhaps infinite. Infinite or simply very large, the key property remains the same. There is no special middle within the space that we inhabit. You might also ask what happens at the level of structure, where things clearly are not homogeneous. The large-scale universe is sometimes called a cosmic web, with filaments of galaxies and nodes where clusters meet, laced around vast voids that are relatively empty. If you plot galaxies in a survey, the picture looks like frost crystals or foam, a beautiful interconnected lace. Does that not give us a center? It does not, because those patterns repeat statistically everywhere. If you zoom out until your field of view spans a few 100 million light years, the map becomes slowly even. There is no supercluster placed so uniquely at the heart that you could draw a line from it and call the rest auxiliary. Our local cluster is one thread among many. The web does not have a middle. It has a texture. Finally, there is the question of speed. If distant galaxies are receding faster than light, does that give us a privileged place? The answer is gentle and surprising. In general relativity, speed limits apply to motion through space, not to the growth of space itself. Distant regions can recede from us at an effective speed greater than light, because the metric that defines distance is changing. That does not allow signals to arrive faster than light locally. In fact, there are horizons beyond which light emitted now will never reach us, because the space between us grows too quickly. Those horizons are another way to understand why our observable universe is centered on us. They are the limits of what light can bring to us, not the walls of an object. Another observer elsewhere has different horizons that are centered on them. The symmetry remains. Among all these pictures and measurements, a theme is emerging with quiet persistence. Every attempt to find a place to pin a center turns into a choice of viewpoint rather than a fact about the world. Translate the coordinate system, and the equations keep their form. Move to a different galaxy, and the Hubble law looks the same. Boost yourself into the calm rest frame of the microwave background, and you still stand nowhere special, because any other observer could do the same for themselves. Even time's beginning in the cosmological sense is a moment shared by all. The universe is simultaneously one story and many perspectives. In the last part of this journey, we will return to ourselves. We will ask what it means to live in a universe without a center, how that knowledge changes the way we hold our own lives, and how humility and wonder can coexist in a single breath. We will let the science rest in the background like the smooth tone of a distant singing bowl, and see what the absence of a middle invites us to notice in the middle of our own days. When you learn that the universe has no center, it can feel at first like something has been taken away. A childhood map has been folded up and removed. There is no throne, no high hill, no place where everything begins. If you let yourself sit with that feeling, though, another one arrives. It is not loss. It is something like relief. The universe does not need a privileged point to be meaningful. In fact, its lack of a special middle is a promise of fairness, a cosmic equal footing written into the geometry of space itself. Every person lives at the center of their own observable universe. That is built into the way light carries information. Your circle, or rather your sphere, is every direction you can reach with light and every direction from which light can reach you given time. Someone standing on a beach across the world, listening tonight with their own breath slow and even, is at the center of a different sphere. Neither is right or wrong. Neither is a claim on importance. It is simply the footprint of perception under the laws of an expanding cosmos. There is something tender in that. The symmetry is not cold. It is a way to say that the universe shows each of us the same dignity. The view from here is as valid as the view from there. Living without a center also shifts how we hold beginnings. The Big Bang was not a blast from a particular spot, but a time when space and energy were in an intimate state everywhere. That means that everywhere is old. Every room you sit in is a place with a past that reaches back to that hot fog. Every breath of air is made of atoms that were once part of that young plasma. The desk, the blanket, the lamplight are all the matured forms of a long cooling. When you think of origin this way, it becomes less of a fireworks show and more like a sunrise that happens across an entire horizon at once. The meaning is not in a point, but in a field. There is also a quiet lesson about maps and choices. We often build personal maps with centers. We place work at the center, or family, or ambition, or care. Those are good maps while they are useful. But the cosmos whispers that many maps can cover the same territory. The way we coordinate our days can be shifted without the landscape changing underneath. You can choose a different origin without the laws of your life changing. There is comfort in that flexibility. The universe grants you permission to redraw your grid when you need to. On a more practical level, the absence of a cosmic center influences how we do astronomy. It instructs us to be careful with selection effects and biases. If the universe looks the same on large scales in all directions, then any strong asymmetry in our data is a clue about our instruments or our local environment rather than the cosmos as a whole. That is how the dipole in the microwave background told us about our motion. It is how surveys calibrate themselves against drifting sensitivities. This discipline, taking symmetry seriously, is part of what makes cosmology a stable science, even as it admits deep uncertainties. The rules are generous, but strict. They do not privilege a place. They demand that we check our vantage points. There is another way that this story comes home. We often hope to be part of something larger. A family, a community, a tradition, a project. The cosmic web is larger than anything our ancestors imagined, and we are genuinely embedded in it. When you look up at night, you are not looking outward from a central sanctuary. You are sitting somewhere within a living mesh that has no middle. That means there is no outside edge to be pushed to. You are not at risk of falling off a cosmic edge. You are not at risk of being lost in a cosmic crowd either. You are one of many centers of observation in the universe that offers the same rules to all. It is a fellowship of perspectives. The lack of a center also gently loosens the grip of urgency. So much of modern life is arranged around races towards central points. The focal point, the key audience, the heart of the matter, the high ground. The universe's evenness suggests another rhythm. There are places where gravity has drawn matter together, cities of stars, and there are regions where the fabric is thin and spare. Both belong. Both are part of the same unfolding. Even the acceleration driven by dark energy is not a sprint. It is slow and patient, a widening that takes billions of years. This, too, can be a model for us. Your life does not have to race toward a single middle to be real. It can expand softly in many directions at once. Sometimes the question comes with fear attached. If there is no center, is there no meaning? Look again at the moon on a clear night. The light that reaches you has crossed space that grows as it travels. It is old and it is new. It lands on your eye and becomes part of you. Meaning is often born in that meeting. A centerless universe still allows centers of experience. You can be entirely at home in a world that does not pick out a coordinate origin. In fact, you already are. Every moment you have ever lived has happened in such a world. The cosmos did not change when you learned this. Only the map in your head did, and perhaps it became a little more spacious. We can bring the science and the feeling together in a simple thought. If someone living in a distant galaxy, perhaps on a planet under a different set of stars, took a deep breath right now and looked up, their sky would tell the same large-scale story. They would see galaxies receding with speeds proportional to distance. They would see a microwave background that is the same on all sides once they correct for their local motion. They would find no center, no edge, only an expanding field with texture that becomes smooth when viewed from far enough away. Their conclusion would match ours. The center is not a place you can step toward. It is a symmetry that treats everyone fairly. So, what does it really mean that the universe has no center? It means that space is not a stage with a marked X where the important actors stand. It means that the laws of physics have been written in a way that holds steady when you shift your point of view. It means that the beginning of things is a time shared by all rather than a location you could drive to if only you had the right ship. It means that your place in the world is not less because it is not the only privileged place. It is precise and complete because it is one of many that are equally valid. If you are listening at night, perhaps you are close to sleep now. Let your breath be easy. The vastness is kind. The absence of a center is a way the universe says welcome from all sides. If you are listening during the day, carry the same quiet evenness with you. You do not have to stand in the perfect middle to be okay. There is no perfect middle. There is a fabric that holds. Thank you for joining me in this slow walk through a big idea. If you would like more journeys like this, told with care and calm, you are warmly invited to subscribe to Hypnosphere. There is always room here for another perspective, another center of observation, another quiet evening of wonder.